Hi, in this video we are going to implement the Prim-Zjarnik algorithm together, and basically we are going to discuss the lazy implementation, so we are not going to update the edge of the priority queue we are going to use. Okay, so first I'm going to create a distinct package with, for example, prim algorithm. Then I'm going to create several classes. One class for the edge, then another class for the vertex, then another class for the Prim's algorithm itself, for example just the algorithm, and I'm going to have an application, so application.java. The edge is going to be the basic edge, so we have the private double weight. We will have the private vertex, start vertex, and we have the private vertex, target vertex. I'm going to generate the constructor, so the weight, the start vertex, and the target vertex. And again, I'm going to change the weight with the last position. Okay, and I'm going to get rid of this super call. Okay, I'm going to generate the getters and setters for the weight, the start vertex, and the target vertex. And basically, because we have to make the decision according to the edge weights, this edge class is going to implement the comparable interface. Of course, we are going to compare two edges. So this unimplemented compare to method is going to return the double.compare, and first we have to compare the weight, and we have to compare it with the other edge weight parameter, so the other edge.getWeight. Why is it important to implement this method? Because we are going to use a priority queue as we have discussed in the theoretical section, and the priority queue must know that according to what we would like to compare our custom object. In this case, the custom object is the edge class. And of course, we would like to compare two edges according to the edge weight. What about the vertex class? It's going to have a private string name. Then we have to create a Boolean flag to track whether we have visited the given node or not. We are going to have the predecessor, so private vertex previous node, previous vertex. Okay, it's going to be private, of course. And of course, we will have the list of edges, the adjacencies. In the constructor, I'm going to have a name, so the string name, and this dot name is equal to the name. And of course, I'm going to instantiate the adjacencies list. It's going to be a new array list of edges. And of course, we have to import the java.util.list. Then I'm going to override the toString method, and I'm going to return this .name. And of course, I will have a method public void add edge, for example, and I'm just going to add this edge to the adjacencies. And I'm going to generate some getters and setters for the variables, for the adjacencies, for the name, previous vertex, okay, not for the name, but for all the other parameters. Ctrl+Shift+F to auto format. Okay, so that's all about the edge and the vertex class. What about the algorithm? The algorithm is quite straightforward. It is like the classical algorithm, that it's going to be very similar to the pseudocode. So we will have a private list of vertices, the unvisited vertices. Okay, we have to import the java.util.list. I'm going to have a list of edges. It's going to be the spanning tree itself. Then I'm going to have private priority queue, because we are going to use a priority queue for making the decisions in the algorithm. We are going to store edges, and basically this is the edge heap, and that's why this edge class has to implement a comparable interface, because we are going to use a priority queue, and a priority queue is going to store edges, and the priority queue is going to assign priorities. It's going to build a heap. And we have to tell Java that, okay, we would like to build a heap according to the weight. So we would like to have an internal order according to the weight in ascending order. Okay, so we have the edge heap, and I'm going to have a private double full cost. Okay, then in the algorithm constructor, we will have a list of vertices, so list of vertex, the unvisited vertices, or the unvisited list. I'm going to instantiate the spanning tree list. I'm going to have the unvisited list is equal to the unvisited list. It's basically all the vertices in the graph at the beginning, and I'm going to instantiate the edge heap as a new priority queue. So I'm going to have a method, public void prims algorithm. It's going to have a starting vertex, as we have discussed, and basically we have to remove from the unvisited vertices this vertex, because we have already visited it. So because we start from this vertex, of course we have to remove it from the unvisited vertices list. Okay, then while this unvisited vertices list is not empty, basically we have to make the iteration, and we visit all the neighbors for this vertex. So vertex get adjacencies list, and if this unvisited vertices contains the edge.getTargetVertex, then we have to add this edge to the edge heap, so the edge. Okay, and basically with this we make sure that we are not going to add any edge to the minimum spanning tree. That would form a cycle. And basically this is very important to check whether the unvisited vertices contains the neighbor, because if it's true, it means that we haven't considered that target vertex, so the neighbor in the minimum spanning tree. And why is it important? Because if we add an edge, then maybe we would add an edge to the minimum spanning tree that would form a cycle, and it is forbidden to make cycles in the minimum spanning tree. So that's why we have to check whether this target vertex is in the unvisited vertices or not. And basically then adding these edges, then we are going to get the minimum edge, so the edge with the minimum weight from the edge heap. So I'm going to remove it, which going to return the edge with the minimum weight from the edge heap. And basically we add this to the spanning tree. So the spanning tree.add, we are going to add the minimum edge. Then we are going to increment the full cost, so it is plus equal to the minimum edge dot get weight. Then we are going to update the vertex to be equal to the min edge dot get target vertex, because in the next iteration we are going to visit the vertex dot get adjacencies. So we insert every neighbor of the given vertex to the minimum edge heap, and basically we get the edge with the minimum edge weight, and then we are going to add it to the minimum spanning tree, and then we are going to update these vertices because in the next iteration we are going to visit its neighbors. Okay, and of course we have to decrement the size of the unvisited vertices list, so we are going to remove the vertex. Okay, and basically I'm going to iterate through so all the edges in the this.spanning tree, or maybe I'm going to, because the spanning tree is a private field variable, I'm going to have another method. So the public void show minimum spanning tree, for example, and here I'm going to iterate through all the edges, the minimum spanning tree, so the spanning tree, and basically I'm just going to system out println edge.get start vertex plus some spacing plus the edge.get target vertex. So basically we are going to enumerate all the edges in the minimum spanning tree. Okay, maybe I'm going to print out the minimum spanning tree cost plus this dot full cost. Okay, so in the next video we are going to test our Prim's Yarnik lazy implementation together. Thanks for watching.